Hello, I'm back again. So, my next point, you see it now on the whiteboard, is to have automation, yes or no. You can of course start without any automation. For example, with a 5 megawatt production, which is only for research and development, just to learn the process. And you can start with a very high level production, which is 600 megawatt, of course with a lot of automation. So, with automation, I prepared 2 points. We have 2 goals which we want to get. So, the first is, you see that arrow, to increase the quality, which means not the price is the problem, the quality, the steady quality of the modules which comes out of the factory has to be as high as possible. So this means, for example, you have EL test. Sometimes we have lines where we had even 2 EL tests. EL test, I don't want to explain now artificial, I just give you a very simple explanation. It's a little bit like an X-ray. When you go to the doctor and you have a broken hand, for example, you go to X-ray and you see, oh, it's broken, you see how it's broken. The same you can do with the EL test. The EL tester looks into the solar cells and he detects even very tiny breaks of the solar cell, which you never see by eyes. Yeah? So if you have 2 EL tester, one before laminating, one after laminating, then you have a very, very good quality station, which increases your quality incredible. There are also another few testing facilities. For example, we call it string tester. There is another testing facility which is called High Automation test. Very important is the so-called flasher. And in this case, you should nowadays go for an LED flasher. And I will not explain this and this because this is not so important. Important is EL test, important is the flasher test. The flasher is something like simulating the sun. It's like switching on the sun, then you see how much watts come out of the module, switching off, and the watts disappear. So it gives, finally, it gives maybe 280 watt result. This is nowadays a very normal solar module. There are a lot of other, I don't want to explain every place now because then we need hours, but all this increases the quality of the products by doing it in automation, which means the EL tester has a feed-in conveyor and an unloading conveyor. The string tester the same, the hyper tester the same, the flasher the same. The only thing you have to do with EL test and only with flasher, you have to switch the connectors, which means the plus and the minus, and then it makes a flash and you get the result.
Maybe before going to costs,
yeah.
Let's talk about the critical parts of the production, because it's not only testing, layup, yes. You can make it by hand.
Okay, thank you. Yeah, let's make another arrow. Patrick is right. Now I concentrated only on quality systems, but there are also some machines which are in a manual mode possible or in an absolute high automated mode. The very simple solution for that is to make it by hand, which means you have a manual stringer, you are placing the ribbons and you are soldering with a normal hot iron. The next luxury step is to have an automated solder station. All the other things are done by hand. The next step is you do everything automated, which means the cells will be loaded onto a soldering conveyor. The ribbons are placed automatically, and the soldering will be done also automatically on a conveyor. This is the highest mode. Finally, you get a string of, let me say, 10 cells. It's a ready soldered string, and an unloading system which loads the ready-made string to a magazine. Yeah? So this is the different levels you can do. The next very important machine is a laminator. The laminator, the laminator can be delivered. Let's say these are 4 modes. It's manual by solder iron. It's manual with solder station. And it's automated. Automated with stringer. And it's 100% automated with stringer. So you see, you have 4 modes. With laminator you have only 2 possibilities. The first is a so-called clamshell solution. And the other one is 100% automated. I give you now a short explanation. Clamshell means you have a laminator, which is maybe 2 meters by 1.5 meters, and you have a clamp which opens, and you take in the modules by hand. And then you have 2 buttons, and you close the laminator, and then the vacuum will be switched on automatically, of course, and 10 minutes, 15 minutes, the module is with 155 to 160 degree melted. So finally you get a fixed laminate. But you have to take it out also by hand. So this is what I call a clamshell solution. There's another solution, which is a load facility, a load conveyor, where you can place 1, 2, 3, 4, 5 laminates. Then the chamber for the laminator, which is at least 4.5 meters by 2.5 meters, and it's the unload facility, normally with a cooling facility. And this I call 100% automated, because it's like a ghost line. The feeding is automatically. The loading in the chamber is automatically. The unloading out of the chamber is automatically. The cooling is automatically. So you need no person to transport, to take the modules in, to take it out. It's all conveyor, it's all 100% automated. Another very important machine is the so-called layup. And the layup, of course, it's the placement of the solar strings onto the glass with the foil. And of course you take 2 persons, one on the beginning of the string, another one at the end, and we say, now let's place. Now let's place the next one. So this is manual layup, and of course with a 5 megawatt, I would say it's a manual solution. Then there are some solutions on the market which are XYZ systems with vacuum grippers. Take the strings out of the magazines and they place it onto the modules. They are doing even the 100 degree turning facility, because you have plus minus, minus plus, plus minus, minus plus. You always have the strings like this, and this, and this, and this. So this is called automated. And there are high-level solutions, which are big robots. Normally they take 2 strings at one time, and they take it from a magazine. There is a centering unit, then they take it from the centering unit, they place it on the module. The glass will be transported into the station automatically, it will be stopped automatically. The foil is still on the glass, and after all the strings are placed, it will be transported out of the station automatically with an unload facility. And this I call robot solution. So, if we talk about quality, the same by the way with the flasher. The flasher you can do manual, but I would not recommend to make any own solution with a lamp or something. It must be a very high professional solution certified by TÜV, because otherwise you cannot give your customers a flash list, we call it flash list, which shows the watt of every module. If you make it by your own solution, then it's not market level, there is no quality behind it, maybe your measurement is totally foolish. So for the flasher, of course, you have to take a machine which is certified by TÜV or by the supplier of the solar factory. And this flasher, of course, can also be manual loaded, can be automated loaded, even you can do the contacting of the plus and minus cables automated with automated placement of the label onto the module. But I think this we can only do, here we are, this we can only do when we have 600 megawatt.
And I think this maybe is a cost matter, because it's not a better quality if you have a label placed by hand or placed by a robot, but you don't need the worker. Maybe then it's a cost.
I'm not sure. Thank you, Patrick. But I'm not sure because in my time, when I was in the production, I saw that the people placed the label, if this is the module, they placed it here, 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 like this, it looks a little bit like drunken. And when the customer came, he said, hey, are your people, are they drinking alcohol? Because the labels, they are placed like a drunken worker. And of course, this is not a quality which is inside the module, but also the outlook of the module is very important. For example, if you buy a car and you have a big scratch, I can say, oh, don't worry, the car will run. You have no disadvantage, but the look, the eye is also very important. On the other hand, you are right, it's also a matter of costs. So now let's come to the second point. I place it over here. You can do automation by decreasing the costs. Here we have increase of the quality, and here we have a decrease of the costs. Which means when we have, let's start again with stringer. Yeah? When we have a manual stringer, you need a lot of people doing the soldering. I saw Chinese factories where 120, it was mostly girls or women, did the soldering, and I saw other solutions where the stringer was done for 30 megawatt or for 100 megawatt, some stringers, and they replaced 120 workers' places. So it could decrease the costs. It depends, of course, how cheap is the labor work.
Do you have an idea how many people per shift you need for each megawatt? Is there maybe one?
It depends on the size of the factory. 5 megawatt, maybe 3, 4 per shift. 30 megawatt, maybe per shift 10, 12. And 100 megawatt, maybe 20, 22. Yeah, it depends on the configuration of the
half automated soldering, you mean, huh?
Please?
So you can say roughly one person per shift per megawatt. 5 megawatt needs...
Yes, I never calculated it like this because I do not calculate with 1 megawatt production. But yeah, roughly, yeah, could be.
Okay,
but not 100 megawatt, means not 100 workers per shift.
Yeah,
5 megawatt means 4 to 5. 30 megawatt maybe 10 to 14 or 12. And 100 megawatt 20, 22, 24. It depends, by the way, on the skill of the workers. The better they are, the less you need. But then, of course, you have to pay more. Okay, this was one point for the costs. Another point for the costs is if you buy material for 5 megawatt, for 30 megawatt, or for 100 megawatt, it's the material cost, yeah? Of course, you get much better prices. So, another point for costs is, you see, I prepared now some figures. For example, for 5 megawatt you need between 4 and 5 people per shift. For 30 megawatt you need about 12 people per shift. And for 100 megawatt you need about 24 people per shift. Now, we can play with these figures. For example, even with, let's not talk about 5 megawatt because it's very difficult to automate 5 megawatt, but 30 megawatt can be more manual, can be more robot automated. And in that case, maybe you can reduce the 12 per shift to 8, yeah? And you have 2 robots to buy, and now you have to compare how much you invest for the robots and how much you invest for the workers. If the workers are more expensive, then maybe this robot solution is better with the 30 megawatt. And the same, we have here maybe 4 robots, yeah? And you can reduce the shift by 12, the people, to 12 people per shift. So you are saving 12 people. Now compare please, is it worth for 4 robots to buy 4 robots and to save 12 people? This is a very important point which reduces, where automation reduces the costs of the installation. We have now, we talked about quality improvements, we talked about some costs improvement. Now let's go step by step through the most important machines. The very simple solution is soldering with iron. And in that case, for example, if you need 30 megawatt, you need 60 people in 3 shifts. Yeah? It's a lot of people only for the soldering. There is a possibility to buy a stringer which is automated, and this stringer can replace, let me say, 55 people in a medium-sized production. Yeah? In that case, 30 megawatt, I didn't calculate with manual soldering. Yeah? This is just now an example. If you decide for 30 megawatt manual soldering, you need 70 people per shift. Yeah? So the next important machine is the layup. So the layup, if you do it by hand, maybe you need 4 people. Yeah? You see, not as much as with solder iron. And when you take a robot, you can save these 4 people, of course. The next station is the laminator. To load and unload the laminator, you need 1 person. If you have a fully automated, if you have a 100% automated laminator, of course, you can save this person. And by the way, you can increase the capacity, because normally the automated laminators are in comparison cheaper and have a higher capacity. So we could do this now for every machine, but these are the most important machines. Maybe the flasher is in the same importance than this one, but also for flasher it's comparable with the laminator, and the automated version you can save 1 person. So we have now 4 example machines. You can reduce with buzzing, you can reduce with junction box, you can reduce with high-pod, you can reduce with EL testing, you can make it automated or loading, manual loading. You can reduce nearly every test facility with automated solutions. And then finally you can calculate how much people you need. And now you see my problem. If I say 5 megawatt, 4 people, 5 people, 30 megawatt, 12 people, 100 megawatt, 24 people. Because up to now, we didn't talk about automation, we didn't talk about the type of the machines, and we didn't talk about is it a 100% automated machine, is it an automated machine, or is it even a robot which is doing much more work and much more workload and replacing much more people, and maybe also giving a higher quality. Yeah? So it's mixed. You cannot always say it's only cost and this is only quality. Sometimes you get a higher quality and you are reducing costs. Sometimes you get lower costs and you are increasing the quality. But finally, I think this is what I want to say for this automation. And yeah, now it's your decision how to go forward and to find your way for your special solution, for your best solution.